Assalamu alaikum. Distance time graph or displacement time graph. What we can deduce from that graph? Let us see. If we have a distance time graph and we will get a straight line passed through the origin, what is the slope of this line? The slope equals the vertical change. The vertical change is the change in distance over horizontal change. So the vertical change, we can say this is d2 minus d1 over the change in time. So this is t2 minus t1. Change in distance over change in time is the speed. So we deduce the speed. So the slope or the gradient equals the speed if it is distance time graph. If it is displacement time graph, the slope or the gradient equals velocity. So remember, in distance time graph, the gradient equals the speed. In displacement time graph, the gradient equals velocity. Let us see this example. We have here distance time graph. Now, in the first interval here, it is a line passed through the origin, has constant gradient, so the speed is constant. So in that part, the speed is constant, and the speed equals the vertical change, which is 50, over the horizontal change, which is 2 seconds. 50 divided by 2 equals 25 meters per second. Now, if it is a flat, like this, it means stationary. So the object at rest or stopped from 2 seconds until 6 seconds. In this part, it is a curve. Curve, it means a changing speed. Changing speed, it means the speed increases or the speed decreases. If the speed increases, it is acceleration. If the speed decreases, it is deceleration. If it is more steeper like this, so this is a steeper line, so the tangent in this part of the curve, the tangent more steeper, so the speed increases, so this is acceleration. Now, in this part of the curve, the gradient of the gradient of the curve less steeper, so the speed decreases. It means deceleration. Now, remember that note. Steeper means faster. Negative gradient, it means returning to start. So if we have here negative gradient like this, it means returning to start. This is a positive gradient. So the first one is a positive gradient. And the last one here, so this is number 2, and this is curve number 3, and this is number 4. The fourth part of this graph, it is constant speed, but here it has negative gradient, so returning to start. Let us see this example. This is a distance in meter time graph, time in second. He said in opposite distance time graph, find the speed in each time interval. Now we have 3 time intervals, from 0 to A, from A to B, and finally from B to C. Now, from O to A, the speed is constant speed. So the speed equals the gradient. So the speed in that interval equals the vertical change, which is 8, over the horizontal change, which is 4. 8 divided by 4 equals 2 meters per second. From A to B, It is a flat, stationary, because the speed here equals the slope or gradient, which is equal to 0. So it is stationary. Now, in the last interval from B to C, the speed equals the slope or equal the gradient. Remember, this gradient is negative, so it will be return to start with that speed. So the speed equals the vertical change. We take the magnitude value. We don't take the negative because it is a speed. Speed is a scalar. So the vertical change is 8 over the horizontal change from 10 up to 18. It means the horizontal change is 8. So 8 divided by 8 equals 1 meter per second. It means return to start with a speed 1 meter per second. Let us solve the questions from past paper about this topic. An object moves at a constant speed for some time, then begins to accelerate. Which distance time graph? Now, let us study each graph. This is distance time graph. So, stationary and then constant speed. This one, constant speed and then stationary. This one, constant speed and then a curve. It means accelerate. So, this is the correct answer. This one, it is a curve. It means accelerate. Next question. 2 distance time graphs and 2 speed time graphs are shown. Which graph represents an object at rest? Now, this is a distance time graph and it is a flat, so this is the correct one because the time go on but stay at the same position. So this is at rest. But A is incorrect. Why? Because it has a line passed through the orange, so this is constant speed. And also C is wrong because this is constant acceleration, and D is wrong because it's constant speed. So the correct answer is part B. I hope you understand this lesson. Thank you.